Assalamualaikum. My name is Nur Naima binti Abdul Majid. So we are from Group 4. We will present for our project. So this project is about a Fourier series. So what is a Fourier series? So a Fourier series is an expansion of a periodic function fx, okay, in terms of an infinite sum of sines and cosines. So the Fourier series make us of the orthogonality relationship of the sine and cosine function. Or in other words, every trigonometric terms in the infinite series has a sign, has a frequency that is in integral multiple or harmonic or of the periodic function fundamental frequency. So it's also referred to as the Fourier expansion. And then the trigonometric form of the Fourier series can be written in a more extended version of exponential function, since the exponential function is connected to sine and cosine by Euler connection. Alright, so for this project, for task 1 and 2, we will choose MATLAB software to do the coding, and we will see the result. Alright, so this is our coding for our project. So we starting the coding with our group name, our group numbers, which is group 4, and then this coding are starting with our group members, which is firstly my name is Nur Naima, and then Muhammad Tanya Hafiz, then Zi Sim Kaiti, and Lee Cheong Lok. Alright, so T naught it is equal to 1, and then tau equals to 0.5. So we have set the T equals to -10. Okay, so the xt we have mentioned here, and for x1, and then we have mentioned the colors of the graph. Okay, so first for n equals to -20 until 20, so this is x equals to tau over t naught multiply by sin and multiply tau over t naught. So we will have plot 411. So we will plot the line graph, and then the color of graph, which is red, and for x level we will label for time, and then y level it will be label amplitude, and this title, which is signal xt for n equals to -5 to 5. Okay, next we have choose n equals to 10, the same function, and then we will change the color and the title of the signal, which is n equal to -10 to 10. And then n equals to 20, the same function like above, and then the subplot, which is 413, and then we plot xt line width to color will be blue, x label, time, y label, amplitude, and the title, which is signal for n -20 to 20. And then the last signal we have mentioned to produce the frequency domain. Alright, so of both graph, and then the subplot 414, the range will be -20 until 20, and then x label n, and the title is xn. So the last title is periodic signal xt and xn. This is the result we produce. I didn't run the coding because the result may be will be delayed. So I do first. Okay, so this is the result that appear like we have mentioned in the coding. So this is the harmonic graph, and lastly the frequency domain graph. The above are the time domain graph. That's all for me. Thank
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dail Hafiz bin Sulaiman, DE21004. I will continue for the project, which is for question 3 and 4. Okay, for the question 3, construct a low pass filter using MATLAB with frequency response characteristic as that given. Okay, this is the given low pass filter, so we need to replicate by using our own FC and FO. Okay, this is our coding to make the low pass filter. Okay, from here we define the resistor, capacitor, and this is the cut-off frequency, and this is the coding. After we run the coding at MATLAB, we will get this result. So from here we can see that the low pass filter is successful because at Y we get negative 3 dB and the cut-off frequency is at 1.1 mHz. Okay, so for the fourth question is analyze the output of the filter both in time domain and frequency domain. Okay, so from here low pass filter, so we need to see the output in time domain and frequency domain. Okay, so this is the coding. We just need to assume for the frequency, the cut-off frequency, this is FO and this is FC. Okay, after that, this is the signal result that we get. So from here we know that if it show the shape like this, it is called as time domain, and the frequency domain, it will show up as this design.
My name is Yichonga, metric number BE20203. Now I'm going to explain question number 5. Question number 5 states that we need to construct a circuit representing the low pass filter your built-in cascade and pass your signal as the input to that filter. Analyze the output of the filter by comparing its output with the simulation. So we are good for session 2. The fundamental frequency given is 110 kilohertz and the cutoff frequency is 1100 kilohertz. And this is the method coding for question number 5. These are the fundamental frequency, cutoff frequency, and these are the low pass filter coding. If we pass our signal to the low pass filter, and we run the method coding. And these are the output stored by the method coding. That's all for me. Thank you.
Hello, my name is Simpatic and I will be presenting about the question 6, which is to investigate the effects of having a lower or higher duty cycle and set the duty cycle for the case of tau equal to 10%, 20%, 30%, 70%, and also 80%. So for our group, which is group 4, we were given the frequency of 180 kHz and also the cutoff frequency of 1100 kHz. And in the MATLAB, we will be setting for both the frequency and also the cutoff frequency. And for the duty cycle for 10, 20, 30, 70, and 80%, you set for them, duty cycle is equal to 0.1, 0.2, 0.3, 0.7, and also 0.8. But the formula of the T is equal to 1 over F, and T is equal to 1 over 10 times with the cutoff frequency, and 5 with T. And we will be returning an array the same size as length consisting of all the zeros. So signals equal to zeros, length duty cycle, comma length T, and we will be defining the loops for complex number runs from 1 to the length of duty cycles. And for the equation of the 5 harmonics, from the n equal to 1 to 5, we will have the harmonics equal to 1 over n times with the sine 2 pi n ft, and signal equal to signal plus harmonic. And n equal to length t fs 1 over t2 minus t1, and we will get the equation of Fourier transform for signal of 5 harmonics. Signal equal to ffts equal to zeros, signals size signals for I equal to 1, size signals comma 1, and we will be shifting the zero frequency component to the center of the signal, and f equal to fs times with negative n divided by 2 to n divided by 2 minus n, and minus 1, and we will be getting the graph for the 5 harmonics in time domain, and we will be plotting the x-axis, y-axis, and also the title. And also you get another figure for the graph for 5 harmonics in frequency domain, and this is the same with the x-axis, y-axis, and also the title, num to string duty cycle. So by running the MATLAB, we will get the figure 2 and also figure 1, and this is it.
Question 7. Identify suitable values for both the resistor and the capacitor. Construct the circuit and show that the analysis in 4, 5, and 6 is valid using suitable simulation software. The low-pass filter of RC is initiated by using additive, subtractive, and discrete derivative blocks, where the formula for RC filter is V in, V out equals to RC dV out over dt, and the values of resistor R and capacitor C will be determined. The filter pair ST and S0. The values of resistor R and capacitor C selected are 1k ohm and 145 pf respectively. The resultant of low-pass RC filtering shown in figure below. Firstly, we insert the resistor and capacitor and then change the value into the value of resistor determined, which is 1k ohm, and the value of capacitor is 145 pf. Then the voltage proof and sine wave generator are inserted. Then the frequency response graph is shown beside, and the voltage probe is dragged inside the graph. The next step is the graph is simulated and maximized to show the final results.
So for the conclusion is, in the summary, signal ST display as consistent and repeatable pattern, classifying it as a periodic signal. After conducting diverse tests, it was determined that Fourier series offers the most effective approach for examining and resolving. An observation during this analysis revealed that increase the number of harmonics result in a proportional increase in the amplitude of the sinusoidal signal, the parameter n, denoting the order of magnitude, signify the accuracy of representing non-sinusoidal waveform as a number of harmonic rise. Nevertheless, it is crucial to recognize that harmonics inherently possess a sinusoidal nature and may struggle to handle abrupt changes, leading to distortion in current or voltage reading. To address the concern, a commonly employed technique involves incorporating a low-pass filter to eliminate high-order harmonic distortion by restricting frequency beyond a specific threshold. Okay, that's all from our group. Thank you.